Okay students, today we'll study about non-stoichiometric crystal defect. In last class, we have done about stoichiometric crystal defect. So today we'll do non-stoichiometric crystal defect. As I have told you, what type of crystals are called non-stoichiometric crystal? For example, if you consider this crystal, nickel oxide, here the ratio of nickel is 1:1, nickel 1, oxygen 1. But in this type of crystal, if you get oxygen 100, then nickel you will get 98. This type of ratio you will get inside the crystal. I mean, the number of cation and the number of anion is not same according to the ratio as given in formula. This type of crystals are called non-stoichiometric crystal, and the defects shown by this type of crystals are called non-stoichiometric crystal defect. So non-stoichiometric crystal means those crystal in which number of cations and anions are not same according to the ratio given in formula. That type of crystals are called non-stoichiometric crystal, and the defects shown by this crystal are called non-stoichiometric crystal defect. Now, non-stoichiometric crystal defect are two types depending on whether the positive ion are in excess or the negative ion are in excess. As you have got, non-stoichiometric crystal means in which number of cation and number of anions are not same according to the formula. So maybe cation is excess or maybe anions are excess. If cation is excess, then it is called metal excess defect, and if anions are in excess, then it is called metal deficiency defect. So there are two types of non-stoichiometric crystal defect. One is called metal excess defect, in which positive ion will be more, and one is called metal deficiency defect. I mean, when anion is more, cation is less, then it is called metal deficiency defect. And you know, in ionic compounds only the metal and non-metal is present. That's why it is called metal excess or metal deficiency defect. So non-stoichiometric crystal defect, there are two types. If positive ions are in excess, then it is called metal excess defect, and if negative ions are in excess, then it is called metal deficiency defect. So first time we will discuss about metal excess defect. This metal excess defect arises due to two reasons: either due to excess of cations, or it arises due to presence of excess of cations or extra cations, and due to anion vacancy. So metal excess defect arises due to two reasons: either due to excess of cations or due to anion vacancy. So suppose this is one crystal in which cations and anions are present like this. Positive means cations, negative means anions. So this is one example of ionic crystal, and in ionic crystal all the cations are and anions are bonded with each other like this. They are bonded with each other. Okay, this is one of the ionic crystal. Positive means the cation, negative means the anions. Here a number of cations and anions are same. Now it is stoichiometric crystal, and here all the cations and anions are in their own position. That is why this type of crystals are called ideal crystal. But this type of crystal exists only at 0 Kelvin temperature. Above 0 Kelvin temperature, it shows some defect. Suppose first time I will tell you about the anion vacancy one. How the metal excess defect arises due to anion vacancy. Suppose one anion is vacant from its position. When the anion is vacant from its position, then it will create one hole. And due to this anion vacancy, number of cation will be more, number of anion will be less, and that is why it is called metal excess defect. I mean cation is more means metal will be excess. Now when this anion is vacant, due to this vacancy, the electrical neutrality will be not maintained. I mean number of positive charge is more, number of negative is less. To maintain the electrical neutrality, one electron will trap this position. As you know, electron is negatively charged, so one electron will occupy the position of anion vacancy. And as you know, electron is negatively charged, I mean number of positive is equal to the number of negative. So here the electrical neutrality is maintained, but the number of cation is not equal to the number of anion. Here cation number is 8, but anion number is 7, and that is why it is called metal excess defect due to anion vacancy. And those crystal in which the electron are trapped in this type of position, it is called the F center. F center means color producing center. Actually F come from one Greek word which is called ferventizer. Ferventizer means color producing center. I mean those crystal in which it shows anion vacancy, and if it contains some electron at the position of anion, then that position is called the F center, and the crystal which produce this type of F center, that type of crystal always become colored one. You know zinc oxide is white, it's white in color, but when you heat it, then it will convert to yellow color. Why? Because when you heated zinc oxide, then the decomposition will take place and it will convert to Zn2 plus ion by loss of 2 electron, and oxygen will be released. This electron released by zinc, it will produce the F center. I mean this electron will trap in the position, and that is why it produces the color center, and that is why the white zinc oxide after heating it turns to yellow in color. So that is why those solid which produce F center, I mean in which electrons are trapped, this type of crystal always produce color. So it may be yellow color, it may be red color, you will get some color for the crystal, and that is why zinc oxide on heating it produce color. Zinc oxide normally white in color, but on heating it produce yellow color due to production of this F center. So this is about the anion vacancy, and this type of defect is called metal excess defect due to anion vacancy. Have you got it? So when some anion is missing from the crystal, then the position of the electron will be trapped by some electron to maintain the electrical neutrality. The electron trapped in the position is called the F center. I mean it produces color, I mean color producing center, and this type of defect is called metal excess defect because cation number is more, anion number is less. That's why this type of defect is called metal excess defect. Now metal excess defect arises due to excess of cation also. How? Suppose this is your anion, here the number of cation, number of anion now same, I mean it is ideal crystal. Now inside the crystal, if some extra cation is entered in the void, suppose this extra electron is come in the void. Now when this extra cation come, then cation number will be more, I mean metal will be excess. Then the electrical neutrality will not be maintained, and to maintain the electrical neutrality, one electron will trap in another void to maintain the electrical neutrality. This is also called F center, and this type of crystal also produce color. Now from where the electron is come? As you know, sodium, when it release one electron, it becomes Na plus. This cation will enter in the position, and the removing electron will trap in other position, in other void to maintain the electrical neutrality. This type of defect is also called metal excess defect because cation number is more but anion number is less. But although cation number is more, it maintains the electrical neutrality. So this type of defects are called metal excess defect, and metal excess defect arises due to two reasons. either due to anion vacancy or due to excess of cations. Now, metal deficiency defect. Metal deficiency defect, it may arises either due to cation vacancy, or due to presence of extra anion. Metal deficiency defect arises either due to cation vacancy or due to presence of some extra anion. This type of defect you will get normally in ionic solid. Suppose this is one of the crystal in which the positive and negative ions are arranged like this. Now, here all the cations and anions are bonded with each other like this. And now it is ideal crystal because there is no defect. All the cations and anions are in their own position. So that is why here now no defect present. Now, in this crystal, suppose one cation is vacant from a position. Suppose this cation is vacant. This is called metal deficiency defect due to cation vacancy. Now, when this cation is missing from its position, it produces one hole. I mean, number of cation will be less, number of anion will be more, and that is why this type of defect is called metal deficiency defect. Cation means the metal, and since the cation number is less, I mean it shows metal deficiency. When the metal is released from this position, then the number of cation is less, number of anion will be more. Then how it will maintain the electrical neutrality? Now in cation vacancy, some positive ions will be missing from the normal lattice side and the extra negative charge is balanced by some neighboring cation, like suppose these are copper 1 plus and these are Cl minus. Now since one copper 1 plus is missing from the position, then what happened? One of the copper 1 plus ion will be replaced by copper 2 plus ion, because you know copper is transition metal, it can show variable valency. Copper can show 1 plus also, copper can show 2 plus also. So one copper plus ion will be replaced by one copper 2 plus ion. Here number of cation is less, 1, 2, 3, 4, 5, 6, 7, but anion number is 8. So here cation number is less, anion number is more. That's why it is called metal deficiency defect. But electrically it becomes neutral now, because total number of positive charge is equal total number of negative charge. This type of defect is called metal deficiency defect due to cation vacancy. I mean, when some cation is missing from its original position, then another cation will be replaced by some neighboring cation. I mean, normally transition metal can show this type of defect, because as you know transition metal can show variable valency. Copper can show 1 plus also, copper can show 2 plus also. If these are copper 1 plus ion, I mean if one copper 1 plus ion is missing, then another copper 1 plus ion will be replaced by some copper 2 plus ion, so that total number of positive charge become equal to total number of negative charge. And that is why this type of defect shown by the transition metal, which can show variable oxidation state. Now another metal deficiency which is due to presence of extra anion. Now suppose this is positive, this is negative, this is positive, there is no defect here. Suppose one anion is entered in one void. When one extra anion is present in the void, then cation number become less, anion number become more. Since cation number is less, that is why it is called metal deficiency defect due to presence of extra anion. And due to presence of this extra anion, number of anion will be more, number of cation will be less. So how it will maintain the electrical neutrality? To maintain the electrical neutrality, one of the cation is replaced by some neighboring cation, like this is copper 1 plus, this copper 1 plus ion be replaced by some copper 2 plus ion, so that total number of positive charge is equal to the total number of negative charge, because it should maintain the electrical neutrality. This type of defect also shown by transition metal, because transition metal can show this type of variable oxidation state. But this type of defect is very rare, because anion, as you know, anions are larger in size. That is why the anions may not be fit in the void. That is why this type of defect is very rare. In rare compounds you will get this type of defect. So when some extra anion will be present in the void, then that extra anion will be balanced by some cation of nearby valency. Suppose 1 plus ion is replaced by 2 plus ion. Like this way it will maintain the electrical neutrality. This type of defect is called metal deficiency defect due to presence of extra cation. So you have got the non-stoichiometric crystal defect. Non-stoichiometric crystal defect mainly two types. Some are called metal excess defect and some are called metal deficiency defect. When cation number is more, it is called metal excess defect. When cation number is less, it is called metal deficiency defect. Metal excess defect arises due to two reasons, either due to anion vacancy or due to excess of cation. Similarly, metal deficiency defect arises due to cation vacancy or due to presence of extra anion. So these are the defects shown by non-stoichiometric crystal. Thank you.